So in this diagram, we are given a triangle. Okay, so wait, I can't say it's a triangle directly, but you can see that PDQ is a triangle. So the first question, you're supposed to calculate the gradient. So 3.1, the gradient of PQ is equal to YP minus YQ over XT minus XQ. Please be aware that these are subscripts. This is a subscript. That's a subscript. Okay? They are subscripts. They must be written on the bottom right hand side of the M or of the Y over the X. They are subscripts. So to calculate PQ, our Y value at P is at 2. The Y value at Q is 0. The X value at P is 0. The X value at Q is at 4. So this will give you 2 divided by minus 4, and that will give you negative a half. So the gradient of PQ is going to be negative a half. Okay, gradient is going to be negative a half. So you should have done this yesterday. Then the next question, determine the coordinates of M. Okay, the coordinates of M. Sorry, of A rather. So let me do it here. So 3.2, it will be, in this case, A is the point, and it's a midpoint. So I was saying A is going to be equal to, I'm going to be very specific, it's going to be XP plus XQ over 2. Right? This is the X value. XP plus XQ over 2 is an X value at A. At A, there's a Y value. It will be equal to YP plus YQ all over 2. Then you close the bracket. It's a point, and they are ordered pairs. They are ordered pairs. So you have an X value, Y value. Then we substitute. Okay, so let's substitute. So if I substitute, it means I'm going to have XP, which is 0, plus XQ, that's a 4 all over 2, and YP is a 2 plus YQ is a 0. You divide that by 2. So the final answer, okay, I'm just going to write it down here. Please be aware that we are dealing with a point. It's a point. So you don't write A equal to. It will be point A, or rather point A, 4 divided by 2 will give you a 2. 2 divided by 2 will give you a 1. I don't want to see someone writing A is equal to 1 like that. No, 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 no. Okay. So don't say I didn't remind you, because I have done so. I've deleted my stuff there, but it can come back. Okay.
So, the gradient, if you say y1 minus y2,
It's the same thing. Right. I think did I explain the y1, y2? I explained that.
oh, that's okay.
Yeah. So I just wanted to, even if you use y1 minus y2 over x1 minus x2, y2 minus y1 over x2 minus xy, it's still the same thing. But it's just that if I'm dealing with specific points, in my case, I prefer to use the letters of those points. Okay. So this will be 1 here. All right. So this was straightforward. Then let's do this question now. All right. Those who did the question, can you tell us what I told you yesterday that you? Right. So here I know the coordinates of A. So let me put those coordinates. X is 2, Y is 1 there. Right. Now, someone might wonder, how is he going to find the equation of AD? It's very simple. I know the gradient of PQ. Okay? So, the gradient of PQ times the gradient of AB must give me -1. What is the gradient of PQ? You calculated it. It's negative a half. You know what? I'm surprised that I'm asking a question and can't give me an answer. It means probably you don't have the answer in your book. Because if you have got it in your book, you must tell me. And why you might not have it, I don't know. So the gradient of AP, okay, remember I told you this, I think I need to emphasize it, since we are getting closer to the end of this topic. Whenever two lines are perpendicular, right, one of them will always have a negative gradient, the other will always have a positive gradient. And one of them, if it has got a gradient which is a fraction like this, means the other one, the gradient must be an integer. Okay, always. So this, right, is a clue to me that the gradient of AP is going to be positive and it won't be a fraction. So if you do your math here, okay, you can write this as minus MAP over 2 is equal to -1. Then you multiply the -1 by 2. So MAP is going to be positive 2. Okay, remember, when I'm teaching analytical geometry, I'm not teaching anybody the basics of solving equations. No, no, no. You have to know how to solve equations. That's what we did in term 1. Okay, you have to know how to solve equations. You cannot end up asking me, how did you get MAP equal to 2? Go back to term 1. Alright, so once I'm done with this now, then I'll say y is equal to mx plus c. So I'm going to determine the equation for AP, for AB. Please be aware that this is AB. Please, this is AB. Okay, this is AB. Right, so let me correct that. This is AB. Right? Okay? So I'll use the coordinates of A together with the gradient of AB, which is a 2. So where there is y, I'll put 1. Where there is m, I'll put 2. Where there is x, I'll put 2. Alright, just to emphasize, I'm substituting the coordinates, those coordinates there. Right? Plus c. Let's see if your c will come out. I'm sure you can see that it's coming out. So 1 is going to be equal to 4 plus c. So c is going to be -3. Therefore, coordinates of B, x is 0, y is going to be -3. Okay. You must use common sense. If you are doing questions on analytical geometry, use common sense. Ask yourself questions. Does my answer make sense or not? Okay. And as I said, this is not the only way. You can also do that using the approach that Tyler spoke about. It's still fine. You will get your full marks. All right. Any question? Okay. Then the next question. Can someone tell us what approach you did this question? Or you did it? Okay. It is produced. So BA is produced. What that means is when you draw line BA, you go beyond BA. So you are producing BA to creating another point, which is a third point. And that point must be collinear with point B and point A, which means the gradient along that line will be the same. So point R can be somewhere by extended, maybe. Okay, I can put it somewhere. That's not perfect, right? It's not perfect. Stop stressing about it, the perfection of it. So this will be 4, 5. So that's how it looks like. So what I'm going to do is, since point P, point A, and point Q are collinear, right? And I know they are midpoint, right? So I can write it. The midpoint of PQ is equal to A And let me not write that to any write it is. Okay, let me just start with the proving that the diagonals are perpendicular. Right? So I know that PQ is equal to, we calculate it was negative what? A half. Right? Then the gradient of MBP, or rather MRB, is MRB is going to be equal to, I can write it as 5 minus, remember I got the value of C there, it was negative 3 divided by 4 minus 0. So that will give me 8 over 4, which is a 2. So MPQ times MRB is equal to minus 1. Then I need to prove this. So MPQ is negative a half times MRB, that's 2. Now when I'm proving that the lines are perpendicular, I need to simplify the left hand side until I get the right hand side. So this gives me negative 1, which is equal to therefore RB is perpendicular to PQ. Okay, so I've done the first part now. That will help me to say that the diagonals are perpendicular to each other. Okay. Then the bisection now, I'm just going to use the coordinates of R and the coordinates of B to recalculate the coordinates of A. If I get the same coordinates as what I got previously, then the diagonals truly bisect. Okay, so then have you got any questions so far? I hope you saw what I did here. This is very important. Okay, that's very important. If you get a question, ask me to prove that an angle is equal to 90 degrees. Those 3 steps are extremely important. Okay? Alright. So
wouldn't it be minus 2?
no.
Because it's only given a fraction, then multiplying by 2.
Okay, look here. I'm talking about minus 2 for what exactly?
Oh, so you just simplify the first.
Yeah, just simplifying the left hand side.
Oh, okay.
In the left hand side, when you multiply the 2 gradients, you must get what? A negative 1. You must get negative 1. And you have to show that. Okay? Yeah, don't say I never heard about it. I'm telling you now. These 3 steps are very important. If you get a question asking you to prove that 2 lines are perpendicular or an angle is equal to 90 degrees, the 3 steps that I just brought there, they are extremely important. And your conclusion. Okay? And your conclusion. Then you can also go ahead and say, therefore, whichever angle you choose there at the point of the intersection of the diagonals, whichever angle you choose. If you choose PAB, then you say, therefore, PAB is equal to 90 degrees. But after writing that, RB is perpendicular to PQ. Okay, so let's move on to the next one. We're just going to calculate the gradient. So the midpoint of RB is going to be XR plus XB over 2. YR plus, you know what? I don't know why this tip of my pen is coming off. And I lost the other one too. So this is YB over 2, like that. So let's substitute the coordinates. XR is what? 4, right? So it means MRB, this is going to be 4, plus XB, which is 0, over 2. This is interesting, right? YR, that's 5. YB, that's -3. So that's our option. So to simplify this, okay, you get 2 under 1. Okay? You get 2 in the what? 2 in the 1. Right? Alright. Now, do you see here that MRB, okay, which is 2, 1, is equivalent to A, 2, 1. Do you see that? Huh? Then you can say therefore, PBQR is a rhombus. Why? You must put the reason why you are now saying that it is a rhombus. Right? The reason will be diags. Okay, just write diags here for a rhombus. Alright. By diags here, we are combining diagonal being perpendicular and diagonal bisecting. Okay. This is based on the examination guidelines in terms of the reasons that I gave you. I hope you still have those reasons. Okay? I hope you still have them. Okay. If you decide that you want to write it in full, write diagonals of a rhombus, okay, bisect at 90 degrees. Okay, you want to calculate what? Diagonal of a rhombus bisect at 90 degrees. If you want, you can do that.
But if we just write the diagonal of a rhombus.
That's also correct. Okay. And then you are done.